Hello, everybody, and thanks for joining me again today. I'll be programming daily again, and so on the agenda is drakon renderer. Let's switch to coding view. This is the first recording I'm making in December, so the year is slowly ending. It's been a fun year. Let's switch to the coding view. Now, if you have noticed, I've made some changes to how we retrieve the title icon and the end icon. I followed suggestions of CodeRabbit AI, and I also did some Googling, and I also asked ChatGPT what would be the best way of arranging those. And the general consensus that I got is if you have monads may be used, you have really a lot of freedom, but what should guide you is common sense. And to me, common sense is this. It just use the functions maybe and return if the value could not be found or provided. Now, but the real star of the show today is this function that will loop indefinitely if we I don't need PowerShell extension. It will loop indefinitely if we switch to primitive diagram 1. So we'll be checking that today. So I hope you have a nice coffee or whatever you choose, and let's write some Haskell today. All right, so let's just prove that it does run indefinitely, recursively. Yep, we can see it's stuck in a loop. I researched some debugging techniques and tracing techniques that can be applied with Haskell. I don't have too much experience with that, but we'll be probably applying that at some stage in the future. For now, though, let's see how far we can get with just plain old reasoning and outputting the results to the terminal. So for now, let's just make sure that this function is not being called recursively. Let's just unlock one execution of it. So this will only return one row, I believe. Yep, which is the top. For those of you who don't remember how it looks like, I think I will have to switch to the lighter theme so you can see what's happening. Yeah, the first row only returns the starting icon, which is workout. Oh, sorry, I made a mistake here because the paths is what we get. We should be mapping the reverse function over a list of new paths. And now we should get a not much more exciting diagram. It should still be very similar. We should get one path consisting of two icons, I believe. Let's see. The title and the first action, or the first question. It depends on what there is. Yeah, one path and two icons, which is not too bad. And I think I have an idea how to resolve this. So I believe the problem with this function seems to be that we're combining a single row with its dependents, while dependents contain elements from the row. So this cycle can never stop. So we already seem to have a function here, get dependent icons with blacklist. Let's see how it works. And the blacklist is already a list. This convergence icons really should be just one convergence icon. Which means that we want to get dependence, but note those who have already participated in the row we're currently scanning. I think this should be healthy enough. Let's see. Let's see the difference. Oh, so if the parent exists in the blacklist, okay, this is why it's not working. If the parent exists in the blacklist, we return nothing. think we should upgrade this function. Because the head of the single row in our case is icon 1. And since it does participate in that row, we're not getting anything. We're only getting that single row repeated. So I think we need to upgrade it slightly and provide 2 blacklists. A parent blacklist. So this is the parent blacklist. Get icon names of dependent icons. Which is just this. Okay. So here we're getting all dependents of that parent, and we're here we're getting a dependent names of that parent, and then we're pulling icons from this collection that match the icon name. So here, really, we should modify this collection of all icons to only contain icons which are not blacklisted. So again, we do a filter. And we filter all icons looking for dependent blacklist. And here which is this. Oh, this is a name. So here, maybe we can just do this. Now we're missing a list of dependent blacklists. So do we use it anywhere else? We don't. So the first run is going to be just oh, beautiful. Thanks, HLint. Another good suggestion. So what we should see now is one path, two icons. And we do. So let's take another step and let's unlock the recursive nature of this function again. It did finish. All right, what do we get? We get one path, which is not exactly correct. Two, three, four. Four we do get, but five we do not get. Okay, so this is progress. Now let's go back to the main function. And what we want to see is, before we even produce balanced paths, I want to see those dcPaths. All right, let's see what we get here. This collection is looking rich, so let's see. So I believe we can delete all that now and start reasoning about what we got. So a quick refresher. Primitive diagram looks like this. So I'm expecting at least two paths. One and path number two. Let's see what we got. Icon 1 and 2. 2 depends on 3, so next should be 3. 3 depends on, 3 has 4 as a dependent, so next should be 4. And that should be the end. So that's the first dcPath. That's correct. All right. Next dcPath should go from 1 to 2 to 3 to 5 and then to 6. Let's see. 2, 3, 5, and 6. So this should be 6. And this is the end. So now let's see what we get. 3 and 3 loops back. So 1, 2, 3, 5, 6. Where's this? 1, 2, 3, 5, 6, and the next one is 3, so we stop. So I believe the dcPaths look correct. Now we just need to trans what? We just need to translate them to this markdown. So markdown is incorrect, but the dcPaths are correct. I'm happy with that. Let's see if we have an issue to cover this. Oh, and I realized that I have been unconsciously advertising Firefox for the beginning of the session. Let's see. So let's the dcPaths function is fixed now. I'm curious what Rabbit AI says about the code. It will probably have some interesting suggestions. And I remember we left it to do. Let's create an issue to address this. Yes. And 1. Would it make sense to create an issue like that? Probably. I mean, it would mean that we would have to provide an interface for this method, which is generating more work. Let's leave it for now. Let's not this. Well, and let's quickly open one PR. that does not close, but contribute. It contributes to issue 130. Get title, get end. And there's also one more issue that I wanted to create, and it's something that I've been researching over the weekend. Cabal or cabal packages as a volume. So this is research. This is not contributing to the milestone. Okay, so what I wanted to do here is, you know what, before I explain it, let's create that pull request. It looks like there is a conflict or a problem. This is not the prettiest function, but it's not supposed to be. Yet, at least. All right, so this is progressing. Now, let me quickly explain the issue that I've just created. Are we good? We're still good. Checking time. Right, so the issue is cabal packages as a volume. So for those of you who have been experimenting with this code on their local machines or in code spaces or wherever, who have been experimenting with this code, you have noticed that my intention was to have this code build and run in containers, specifically using this Docker file. So what this Docker file is just it prepares an image where Alpine 322 is the base. And it installs all the packages one would need to install GHC and Cabal. Even though the image ends up being pretty big, I believe this is a reasonably compact image. But the problem I have with this is it takes a little while to build, which is fine. But then when the container starts and you want to work with your code and run a Cabal build or a Cabal run, for the first time the container starts, it takes a lot of time. The reason why it's happening is containers are ephemeral, or the containers I'm using are ephemeral, and they are not really modifying the host environment in which they are hosted. And this is why every time a new container starts, it needs to populate Cabal with all the packages on which the code depends. And this is happening because I only have 2 volumes. One is I'm sharing my SSH keys in order to use Git from within the container. And also I'm sharing the current directory in order to have the code available in the container to build it. What the problem seems to be is that all the packages generated by Cabal or the information about packages generated by Cabal inside the container is lost the minute the container stops. You see this --rm parameter. So I did some reading, and it looks like all these packages can be preserved from container to container if we mount them as a volume. If it's as simple as that, I would be very happy. So those packages seem to be here. In Cabal somewhere. Let's see where Cabal is installed. But this is probably something that we'll be figuring out later. Cabal config. And I don't see any Cabal here. Let's see. Oh, there's Cabal here. I'll try to do some reading, but what I would like to do is to streamline the development environment that you have locally by resharing Cabal-generated package list and information from container to container. So we'll be doing that at some stage. But for now, I'm pretty happy with the progress I've made today. I would like to thank you for your attention. Next time on the agenda, we'll be progressing through the process of translating dcPaths into Markdown. Hopefully that's not such a hard issue. And maybe by the end of this week, we'll also look into those Cabal packages. Yeah, I think we can wrap it up today. Have a fantastic day, everybody, and see you next time. Bye.